Hey y'all, it's me, Miss B, and today we're working on condensing and expanding logarithmic expressions. Okay, so here are product rule, quotient rule, and power rule, as well as a change of base formula. So with the product rule, if I have two things being multiplied with base b, what I do is I add those two things together. It says minus, but you should change that to a plus sign. That was my mistake. So that becomes log base b of m plus log base b of n. Again, keeping the same base. Quotient rule, if we have m divided by n, we subtract those two logs. So log base b minus log base n. Then for the power rule, if I have log base b of m to the p, what happens is it moves out to the front and becomes p times log base b to the m of m. So we can move either way. We can move from right to left or left to right, depending on which one suits us for each problem. So, and then we have some general properties down here. These can be useful, especially the natural logs here. These are useful when we are looking at simplifying all the way down. Okay, so here we're going to expand these expressions. So I have log base 4 of 10x. Now, since I have 10 times x, I can rewrite that as log base 4 of 10 plus log base 4 of x. And I actually, the way I would write log from here on out is I would write it as cursive, just so it doesn't look like 10g. That's something that I have a tendency to get confused on, so make sure you go ahead and write that with a little cursive log, or make it fancy so it doesn't look like 10g. All right, this next one here, we've got log base 4 of 7 times 5, so go ahead and rewrite that one. You should have got log base 4 of 7 plus log base 4 of 5. All right, next up, we've got log base 7 of 19 over x. So what that means, I'm going to have log base 7 of 19 minus log base 7 of x. So it's subtraction with division there. Here I have ln of e to the 3 over 7. Go ahead and try that one. So what you should have got was ln of e to the 3 minus ln of 7, because log base e is that. And so when we have ln of 3, or ln of e to the x, what we get is x. So this becomes 3 minus ln of 7. Finally, I've got log base 5 of 7 to the 4th. This 4 is going to pop out front using the power rule. So I have 4 log 5 of 7. All right, and then this next one here, it's a little challenging, but I want you to try it on your own. Okay, so you should have started out by writing this as ln of x to the 1 over 2, which you would have had to throw it back to algebra 2 for that. And then we're going to take this 1/2 and move it to the front. So we have 1/2 ln of x. Okay, and then we're going to save these ones for class. All right. Condense the following. Okay, so first, let's start by getting it so the logs are the only thing out front. So for this one here, I'm going to take my power rule to move this up to the top. So I have log of 4 to the 3 plus log of x. So because I have 4 to the 3 and x, I can multiply those things together. So I get log 4 to the 3x, which is equal to log of 64x. So that right there is my final condensed answer. Let's look at this next one here. So for this one, I'm going to have to use a change of, well, let's get there in a second. So I have log base 4 of 2 and 32. So I'm going to do log of 4, 2 times 32. So I get log base 4 of 64. Finally, I've got ln of x plus 7. So I'm going to rewrite to bring that 3 up here. So I have ln of x plus 7 to the third minus ln of x. Now I can't do anything with this in here, but I can take this and make it into one log because of the subtraction right here. So I get ln of x plus 7 to the third all over x. That right there is my final answer. Okay, these ones over here, we can practice in class. All right, finally, so we want to evaluate log equations that are not in base 10. So here, this is log base 5 of 140. And if you remember, something in base 10 would look like log of 7, where this is equal to log base 10 of 7. So it's like an invisible 10 right there. So the way we're going to do this is by using the change of base formula. So what I do is I take log of my big number over log of my small number. So it's going to be log 140 over log 5. And I changed it into a base 10. Now, I can change it into whatever base I want. And I would even make note of that up here if we haven't already. So change into whatever base we want. So most of the time we want to use base 10 because base 10 is in our calculators. But sometimes it makes sense for us to use different ones just because it's easy to evaluate. So if we plug log 140 over log 5 in our calculator, so functions log 140 divided by log 5, we get 3.07. Now, of course, we can use log base whatever in Desmos, but on a regular calculator, we're not able to, so you will need to show this work to evaluate it, since that is how we're doing it in this class. So this is 3.07. I'm going to use my squigglies. Okay. I'm going to save this one. But I want to look at the use of change of base form using the natural log. So we can use whatever base. So I'm going to go ahead and do ln of 140 over ln of 5. Type that in. So if I type ln, I wonder if it comes up. ln, no. 140 divided by ln of 5. So I get 3.07 again. And you could see that I could do, if I really wanted to, log base 3 of 140 over log base 3 of 5, and no matter what my base is, I'm going to get the same answer every single time. So that's just also going to be 3.07. So we can use whatever base we want, It's really up to you. ln's really easy to find on the calculator, so is log. However, those other bases are not easy to find. So that